Hello everyone and welcome back. So this time we're going to try an example of using this whole couple force moment system thing. So what we're trying to do is we have this pipe, and this pipe has a couple of forces applied to it, no couple moments, so we're going to take all these forces and turn them into one force couple moment system. And it has to be equivalent, that means it has the same external effect. So how are we going to do this? Well, you're going to sum all of the x and y components to find the resultant force. That's easy, that's simple to do. And then I have to summon all the moments resulting from moving each force component to A. Remember, where we move them to matters. Because if I move this, 2 inches, that's going to have a lot less effect than moving all the way over here. Because that large movement causes quite a bit of a moment. Okay. And the final thing we're going to do is figure out where we can move FRA, the resultant force, such that the distance d from A will cause the moment that we have. So we want to get this from a couple moment, a force moment system to just a single force. We can do that because these are coplanar forces. So stop, work on this for a little bit, try it out, and then come back and see how it went. You can walk through it again with me, or you can see where you got stuck, or you can just verify you got the right answer. So 3, 2, 1, you paused, you come back, maybe you had something to drink, we could bake the cake, and now let's jump into it. So the first thing we need to do is break up all these into components. We'll start with the x direction. That's typically what we do. We have an angle here. We have a slope triangle here. This one's pretty simple. So in the x direction, I'm going to have 3 over 5 of 100 pounds, because that's how it works. I use the horizontal component of my slope triangle over the hypotenuse and multiply that by my magnitude. So 100 times 3/5. And up here, if I'm looking at it, I have to be very careful because this is where people get confused. The x position is not going to be with cosine, but with sine. A lot of people just like default saying, well, cosine for the x. It's not that case. It's always, got to look at it adjacent, opposite. Which one is that connected to? In this case, opposite is going to be equal to my x direction, okay? So with that in mind, I have to use sine of 30 degrees to get that. And very much similarly, I have 200 pounds going straight up from this guy. I have cosine of 30, because that's the adjacent side for this force. And I have 4/5, because that's the other component of my slope triangle over the hypotenuse for this last force. With x, they're all pointing in the same direction. Don't have to worry about signs. For y, I do have to worry about signs. And this 100 pounds is pointing down, so it's negative. So I can get my components here. And then from this, I can determine the effect of moving my forces all the way to point A. It's not too terribly difficult, because in the end we only have to worry about the y components, because the y components are the only thing that's going to cause a moment around an x movement. Okay? So I have 200 moved by 3 feet. Makes sense. I have 50 cosine of 30, which is the y component. Moved by 9 feet, all the way from here. And I have 100 4/5 times 6 feet. So it all works out. And we get 509.7 pound-foot, and that's counterclockwise. Counterclockwise. Last thing is to figure out what is the equivalent single force and where can it be located. One thing to think about is that equivalent single force is not necessarily just straight up and down. It's probably going to be at an angle. In this case, it is at an angle of 62.5 degrees with the horizontal. So to find that distance, I just take my magnitude of my moment and divide it by the magnitude of my force, the resultant force in the y direction in this case, because the distance I'm moving it is in the x direction. And it will be 3.12 feet. So a resultant force at this angle and this magnitude, that's 3.12, roughly like right there, away from point A, would have the exact same effect as all these forces. So we have simplified our situation. So hopefully this is starting to make a little bit more sense to you now that you've seen it done. If not, we've got a second example for you, and we'll keep on doing these problems until hopefully it has clicked. So I'll see you all next time as we continue to work through some more force moment couple systems. Have a good day. Bye-bye.